Oh, there again. So this is my second video on gradients. If you've not watched my first video, just have a look at it because it gives you some sort of idea of what it's all about. Okay. Otherwise, what I'm interested in is how to find the gradient of each one of these straight lines. And I've deliberately put a few on there on purpose. Okay. Not to make it look confusing, but because if we're trying to pick out which lines are more steep, which lines are the steepest, then calculating the gradient is incredibly useful. And that's what gradients are all about, trying to work out the steepness of a straight line. Let's have a look at how we do it then. So essentially you need 2 points. Okay, you can just mark off 2 points, any 2 points you want, and then you work out what the gradient is between them. So here, essentially you've got one coordinate point, I'll call it x1, y1, x coordinate, y coordinate, and the second coordinate point, x2, y2. Okay, you just choose any 2 points. Now this could be your straight line graph, but what we're interested in is what the horizontal and vertical components are, what the horizontal distance, if you like, is between the 2 points and the vertical distance. And what we'll do is we'll work out the difference in y coordinates. So in other words, what this distance here is, that is y1 minus y2. The order doesn't matter. In case you're wondering whether to do that, subtract that, or the other way around, it does not matter, and you'll see in my examples coming up. And then we'll do the difference in x coordinates. So there's x1 and x2, the difference between those. Again, the order doesn't matter, but you've got to be consistent. So if you could do that, subtract that, you do that, subtract that. Don't mix it around, otherwise you can end up getting it wrong. Okay, and that's our gradient. That's how we calculate it. Okay. Alternatively, if you don't like the x's and the y's, just think of it like this. What is the change in horizontal between here and here? What is the change in vertical between here and here? Just be careful about counting squares if that's something you do, because it's not always the case that it's 1 square per unit. You've got to check on the scale to see how to do the change in horizontal and vertical. And you do it this way around. Please, please, please remember the order. It's change in vertical over change in horizontal. Okay, the y's over the x's. Okay. Now you might have come across this formula, you might have seen it before, but that's rather important. Okay. More on that later. What I'm going to do is I'm going to give you an example of how to calculate the gradient. So this is what I showed you earlier. I'm just going to get rid of some of these lines. So we're left with this one here. Okay. You might have seen the equation already, which might have given it away. It doesn't really matter. We're going to try and work out the gradient of this straight line. To do that, let me just do this. Right. What I'm going to do is I'm going to choose any 2 points that line out. It doesn't really matter which ones, any 2 points. Okay. So that's be interesting. Let's choose that one down by there. So that's got coordinates 0, -3. Doesn't matter that it's negative. This happens a lot. Sometimes you've got no choice and you've got to take a negative coordinate. And choose another point that lies in the line up there. So that's got coordinate 5, 7. Now, if you check out the scaling of my graph, you could probably do this by counting squares, but it's probably not a good idea to do it. Okay. So what I'm going to do is I'm going to do the change in y coordinates first. So I'm going to write out that, subtract that. Doesn't matter which order you do it. I'm going to show you both ways, okay? So 7 subtract -3, which is of course 10. Yeah, 7 plus 3. 7 subtract -3 is 10. Okay, so it's just 10. And then difference in the horizontal component. So I'm going to do 5 subtract 0, which of course is 5. 10 divided by 5 is 2. Now, if I did it the other way round, let's see what would happen. Okay, so if I did that, subtract that, let's write that down. So if I did -3, subtract 7, what does that give me? It gives me -10, doesn't it? Yeah. And then keeping the same consistency, because I did that, subtract that, I'll do this, subtract this, 0 subtract 5. What's that? That's -5, isn't it? And -10 divided by -5 is +2. So notice in both cases you get exactly the same answer. You get a gradient of 2. But also notice it's sloping upwards, always reading from left to right, as we do with graphs. Notice how the axis increases from left to right. So that's how we read it. We always read a graph as left to right. Because it's sloping upwards, the gradient will always be positive. Okay, the gradient will always be positive for a line that's sloping upwards from left to right. So if you do make a mistake somewhere, just check your work and you should get a positive answer. That's the gradient of that line done. Let's just do another one. So I'll just get rid of that. Let's do a nice easy one next. Here we go. Let's just put on this one. Okay. It's the graph y equals x. You've probably spotted that already. I'm going to choose any 2 points. Let's just choose these ones because they're really easy. Okay. So I've chosen the origin and I've chosen the point 5, 5. Okay. If you want, you can do it by counting squares because it is 1 square per unit. So you've got 5 squares that way and 5 squares that way. Or you can do the same as before, do 5 subtract 0. That's the change in vertical components, and 5 subtract 0 again. That's the change in horizontal components. 5 divided by 5 is just 1. Okay. Which is what you expect for a straight line graph. Y equals 1. Sorry, y equals x. The gradient is equal to 1. Let's do another one. So I've got plenty here to do. So let's just get rid of that and let's put this one this time. You can already see, compared to the first two that I did, there we go, that the purple line is flatter, it's shallower, it's less steep. So you'd expect a number that is less than 2 we had for that one, and a number that's less than 1. You might be able to guess what it actually is, okay? Particularly given the equation of the line, y equals a half x, if you've seen the relation between the equation of the lines and the gradients. So I'm going to do the same as what I did before. I'm going to choose any 2 points. It doesn't always have to be the origin, it could be any points you wish. Just to be different, I'm going to choose a point down by there. So that's got coordinate -10, -5, -10, -5. And I'm going to choose this point here. Just be careful when you choose them because you do want to have points that the line clearly goes through. You don't want to, for example, try and work out what that point there is because it looks a bit awkward. It doesn't look like it's an exact. So have a point that you know definitely lies on the line. Okay. Now, if you want, you can draw out the triangle for these. Some people like doing that. And just draw that as a nice bold triangle. You don't have to, okay, but some people like doing it. And again, if you want, you can label on the triangle what the horizontal and vertical distances are. So from here to here, you can either count the squares or look at the difference in the x-coordinates. It's 20. And then from here to here, you can either count the squares or look at the difference in the y-coordinates. It's going to be 10. Or if you want, just do the calculational approach. So if I did this pair of coordinates, subtract that pair of coordinates, I would have 10, whoops, let's do it properly, 5, subtract -5, always the y-coordinates as I mentioned, do -5, subtract -5, all over 10, subtract -10, and what's that same as? 5 subtract -5, that's 10, and 10 subtract -10, that's 20, 10 over 20, that's 1/2. The gradient is 1/2. It's positive because it's still sloping upwards, left to right, but it's a shallow line, so the gradient is 1/2. Okay. Have you seen already what the relationship is between the equation of each line and what the gradient actually is? So the first line we did, the equation was actually this one, y equals 2x minus 3, and the gradient was 2. I'm using that to m to represent the gradient. We use m to represent the gradient, not g, something else. Okay. Here, for the red line here, we've got a gradient of 1. So the gradient for that line was 1. And then we've just done this one, the gradient of that is 1/2. Have you noticed something? A link between the actual equation and the gradient in each case? I'm hoping you've noticed something. If you haven't, just have a guess. Have a think about what you think the gradient of that line will be. The green one, much steeper. Now you can either work it out. To work it out, you just choose any 2 points that lie in the line. So, for example, you could choose that point there, clearly lies in the line, and that point there, clearly lies in the line. Or, by now, you might just be able to look at the number in front of the x, called the coefficient of x. The gradient is 3. Okay, so that's a rather nice handy result, isn't it? The number in front of the x on the straight line graph is the gradient. Wow, how cool is that? That is mathematics. Okay, that's an example of coolness in action in mathematics. Okay, so these ones are not even put on yet. Okay, but can you see first of all this one? It's sloping downwards. It's got a negative gradient. Notice it says y equals -x. Okay, I don't think about what the gradient would be. It is -1. It is -1. You could work it out yourself if you wish. Do the calculation. You'll get -1. What about this one here? So I'm going to put it on. The equation says y equals -2x plus 1. That's the graph there. It's an orangey graph. It's sloping downwards, so it's a negative gradient. It's steeper than this black line here. It's just -2 though. It is -2. Okay. So what I'm saying to you is, if you're given the equation of the straight line, you can just read off what the gradient is. But suppose I were to cover all those up. Suppose all you had was the actual lines in the graph, well, you have to actually work it out. That does help us to find what the equation of the line is. Now, one final bit for this video. What is the number on the end? Okay, what's that referring to? Let's just change my colour this time. Okay, so what is this number on the end, the -3? Okay, well, let me just highlight which particular graph that actually is. So let's just get rid of those. There we go. So that's the graph there. The -3, that's actually the y-intercept. Okay, so this -3 refers to what we call the y-intercept there. That is where the straight line crosses the y-axis. It doesn't have to be a straight line, it can be a curve. Okay, any graph where it crosses the y-axis is -3. It's as simple as that. Why does that work? Why does that work? Well, if we consider the equation y equals 2x minus 3, remember, to find a coordinate that lies in the graph, we just substitute in the value of x. If I put in x equals 0, 2 times 0 subtract 3 is -3. So y would be -3. Remember, that's how the equation works. You substitute an x coordinate, you get a y coordinate back again. So x is 0, y is -3, and that's the coordinate point there, 0, -3. So the y-intercept is always going to be when the graph crosses the y-axis, when x is equal to 0. Let's just get rid of that. Let's put another one on. Can you see this time why the y-intercept is 0? It's because the equation is y equals x. The equation y equals x, when x is 0, y is equal to 0. Let's do another one. This one here. So this has got equation y equals 3x plus 3. Can you see that the y-intercept there is when y equals 3, and you've got plus 3 there. Okay. Can you tell me what, without showing you a mind what the graph is, what this one is going to be? So it's y equals -2x plus 1. Y equals -2x plus 1. Of course, the y-intercept is going to be 1. So the graph is going to go through 1. And do you remember what it looks like? The -2, sloping downwards, relatively steep. Okay, so you've got some sort of idea of how to draw it before I even show you. Okay, but there it is. Okay, so y equals -2x plus 1. Okay, going back to this again. Well, oh, there we go. Almost lost it. Okay, so come back to this. Y equals mx plus c. Notice all of those equations were written in this form. Okay, so if I give you another one, a different one, if I give you the equation y equals 7x plus 5, without drawing it, would you be able to tell what the gradient and y-intercept is? I'm hoping yes. Okay. The gradient is just that number there, 7, not 7x. X is the actual variable that is in the equation. 7 is the gradient. Okay? What that means is for every unit you travel horizontally, you travel 7 units upwards. Okay? The y-intercept is 5. Okay? So it's as simple as this. We use letter m to represent the gradient, and whatever letter that is, we just write it in the equation, y equals that gradient times by x. And we use c, a constant value, which is where the c comes from, as the y-intercept. Okay? So if I give you another one, y equals 1/4 x minus 2. Would you be able to tell me what the gradient is? Of course, it's 1/4. Do you understand what the y-intercept is? Of course, it's -2. Okay? That's essentially what you need to know about gradients, but they're very, very important, very, very useful, very extremely important. Okay, I'll just give you an idea of why. Because by the time you get to this sort of question, year 11, year 12, you need to be able to know at the very least how to find the gradient of a straight line if you're about to tackle that question there. Okay. I'm just going to leave you with this. I'm hoping you found that extremely useful. Thanks for watching, and I'll see you again. Bye bye.